Hi, I'm Dan Cortopassi. Welcome to Model Building. In this series, I'm making HO scale models of 5 locomotives that I saw in the front of a Southern Pacific freight train in 1993. In the last episode, I worked on preparing some LEDs for my Conrail SD40, number 6283. Before that, I started to build a custom speaker enclosure in the rear radiator area and prep the shell for lighting. My goals for this time are to install the rear number board lights, install the rear marker lights, and finish the speaker enclosure. Before getting out the soldering iron, it's good to come up with a lighting plan for a model. DCC decoders have lighting outputs that are like light switches. Each lighting output can control one light or a set of lights. The thing to remember is that each light that's attached to the same output will go on and off at the same time. Likewise, if any effects like blinking are assigned to that output, then all the lights in that output will do the same thing at the same time. That means if you want independent control over different lights, they need to be assigned to different lighting outputs. In the DCC world, the most common example would be front and rear headlights. Generally, you don't want the headlights on both ends of the locomotive to be on full bright at the same time. Most of the time, the light shining in the direction of travel is bright, and the light on the opposite end of the engine is dim or off. To achieve that kind of independent control, the front headlight and rear headlight have to be assigned to different lighting outputs on the decoder. Any other lights, like number boards, or in the case of my Conrail engine, the red marker lights, also need separate outputs. One of the exciting things about the LokSound 5 DCC decoder that I'll be using in this model is that it has 10 lighting outputs. That allows independent control of up to 10 different sets of lights. Before this decoder, the most lighting outputs commonly available in a small-scale decoder was 6. Even though this is a Conrail engine, this decoder was made for SP modelers, I think. I need to find a way to have some fun with that. I can start by making a list of all the different lights that I want to control independently on this model. For example, I'm not 100% sure about prototype Conrail operating practices, but to be on the safe side, I want to be able to control the front and rear red marker lights independently. When I built this engine the first time, I had a decoder with fewer outputs, and I grouped the markers together, which meant that they were either all on or all off. I remember someone telling me that the markers on the real engines could be lit up on one end only, so I want to be able to do that on my model. In the past, I've usually grouped number boards together into one output. I still don't see a big need to control the front and rear number boards independently. However, since I have the lighting outputs available, I'm going to separate them. The LokSound decoder has a brightness adjustment on each output, and having the front and rear number boards separate would make it easier to tweak them so that the brightness level on both ends of the engine is about the same. I can still group them together logically with programming so that they operate with the same function key on my DCC controller. So let's see what we've got so far. Front headlight, rear headlight, front number boards, rear number boards, front markers, rear markers. To do just that much would require 6 lighting outputs. Since I have some additional outputs to play with, I can also add a cab light and ground lights. That brings us to a total of 8 outputs. I'm going to start by installing some of the LEDs that I prepared last time in the rear of the locomotive. First, I need to make a light box for the rear number boards. I still have some of the plastic that I used to make the barrier that forms the top of the speaker enclosure. It's already cut to the correct width for the inside of the shell. I'll tape a piece to my plate glass. Next, I'll put this surplus Kato SD45 shell on it. I can use the contours of the nose to get the angles right to fit the hood ends. With the shell and frame side by side, I can measure the distance between the part of the frame that sticks up in the rear and the end of the long hood. It looks like at least 5 or 6 scale feet. I'll cut the top of my light box to about 3 scale feet. The exact size doesn't matter as long as it fits. I cut another piece the same size for the bottom of the light box. The top of the light box is getting caught between the headlight fiber optics and the existing clear plastic behind the number boards. I'll need to cut a notch in it. It's also hitting a piece of the grab iron that's sticking through the shell, so I'll need to file another small notch in the corner. Now it seems to be fitting pretty well. Before I glue it in though and cut off my access, I'll need to seal up the top of the speaker enclosure. Having an airtight seal makes for better sound. I like to use RTV silicone to seal enclosures. It comes in a variety of colors, none of which really matter since it won't be seen. This one is black. I got this tube at an auto parts store. Many hardware stores also carry similar products. I like to use a small screwdriver as an applicator. It's not that pretty, but it'll make the enclosure airtight on top. I'll be using more of this stuff later. It's okay that a little bit got on the fiber optic strands. That won't hurt anything. Now I can install the top of the light box. It fits on top of the clear piece that sticks into the shell. The clear piece is a remnant of the original Kato light pipe for this model. The silicone will help to hold the top of the light box in place. I'll set the model aside for a while to let the RTV cure. To make the back of the light box, I need to measure the height of the number boards. They're about a scale foot. I'm going to cut a piece of plastic slightly taller, 1 1/4 scale feet. Again, the exact size doesn't matter, but it should be at least as tall as the number boards. Now I'll drill 2 pairs of holes with a number 74 drill bit. Each pair of holes is roughly centered behind one of the number boards. I'll take a pair of the warm white 603 LEDs that I made last time and thread the leads through the holes. Twisting them in back will help to hold the LEDs in place. Be careful not to twist the wires too hard and pull the leads off the LEDs. They should be just tight enough to stay put. The back of each LED should be flat against the plastic, not hanging at an angle. I'll test them again to make sure that I didn't break anything. They both still light up, which is good. Sometimes just twisting the wires isn't enough to get the LEDs to lie flat. A drop of CA will help to hold them in place. After the glue is dry, I'll twist both sets of red and green wires together. When I'm done, I have 2 braided strands, one red and one green. Before I glue the back of the light box in place, I want to put a little black paint on top of the box to help prevent light leaks. I'm using liquid styrene cement to secure the back of the light box. LEDs typically have an extremely long life, so I'm okay with gluing them into the model rather than making them removable. Next, I'll solder both green wires together and cut them shorter. Now I can feed the wires through one of the holes that I drilled in the front of the speaker enclosure. I'll temporarily solder the red wires together too, and then cut them. This makes it easier to thread them through another of the small holes. Once they're through, I can clip the soldered end of the red wires so I can untwist them a little. With the ends separated, I can re-tin them. Since the number boards don't have to be super bright, I'm using a pair of 2K ohm resistors. I'll twist them together on one end, then solder them. Sprung tweezers are handy for holding small parts like this. Note that I've already put some heat shrink tubing over the red wires. Each of the red wires is connected to a resistor. For consistent brightness, it's important that each LED has its own resistor. Next, I'll use the soldering iron to shrink the tubing and insulate the connections. Now's a good time to hook up the LEDs to the tester again and make sure they still work. Looks good. I've painted the inside surface of the bottom of the light box black, again to help prevent light leaks. Before I glue it in, I need to make a couple supports. I've cut 2 pieces of 040 styrene strip to the same height as the back of the light box. I'm gluing one of these on each side. These pieces also help to seal up the back of the box. Now I can install the bottom of the light box. I'm a firm believer in testing things as you go. This is what the number boards look like connected to my test battery. Before I install anything else, I'll use my sprue cutters to trim the fiber optic leads for the rear headlight shorter. This will help keep them from getting in the way. It would have been better to do this before messing around with the number boards. Next, I'll cut a short length of 1/16 heat shrink tubing and use it to bundle the fiber optics together. I'm not actually using heat on it as that could damage the fiber optics. It's basically just a tube to keep the strands in the same place. I'll be using the red LEDs that I prepared in the last episode to light up the rear markers. First, I'll need to make some mounts for the lights. I'm going to hold a piece of 040 styrene strip inside the rear corner of the shell and put a number 76 drill bit through the hole in the marker light opening. I'll drill just enough to put a dimple in the plastic. Now I can use the dimple to position the drill to finish the hole. I'm cutting that piece and using it as a template to make 3 more identical pieces. The exact length doesn't matter as long as it fits. I'll remount the holes in 2 of the pieces with a 1/16 drill bit. The holes in each piece are slightly offset to one side, so I need to make sure to flip 2 of them over so I have right and left pieces. Next, I'll laminate one of the pieces with the small hole to one of the pieces with the bigger hole, making sure that the small hole is centered in the larger one. I've cut 2 more pieces of 040 styrene strip without holes in them to match the pieces I've already made. Now I can take the red LEDs that I made last time and mount them. I'll file a shallow channel for the wires on the pieces with the large hole. The LED goes face down in the larger hole so that the light is pointing toward the smaller hole. I'll laminate the blank piece of styrene strip over the back of the LED to hold everything together. At this point, it's a really good idea to hook the LED up to the tester and make sure that it still works. The LED looks brighter on video than it does in person. These glow a little, so I'm painting the outside black. I have to be careful not to get any paint inside the small hole. Just like I did for the rear headlights, I've created a pair of lenses for the rear marker lights by using heat to flare the ends of fiber optic strands. The only difference is that I'm using 020 diameter fiber optics for the markers instead of 030. I'm going to paint the marker lenses with Tamiya Clear Red acrylic. This will tint them red but still allow light to shine through. Sprung tweezers are also handy for holding small parts while painting. While I'm at it, I'm going to carefully paint the front marker lights as well. These still have the old fiber optics installed from the first time that I worked on this engine, but I never got around to painting them. Now that the paint on the rear marker light lenses has had a chance to dry, I can push them through the holes that I previously drilled in the shell. I'll use a drop of canopy glue on each one to hold them in place. You could also use white glue. I prefer canopy glue to CA in this situation as it's more forgiving if I get any on the outside of the model. I'll flip the model over and give a gentle tug on each fiber optic strand to make sure that it's fully seated. Next, I'll clip the leads through the shell short so that just a bit of fiber optic sticks through. My original plan was to put the blocks with the LEDs in them behind the class light openings, fitting the fiber optic strands into the holes that I drilled. Then the blocks with the LEDs could be glued inside the shell. Unfortunately, this proved to be extremely tricky to get everything aligned. After several failed attempts, I decided to try it a different way. Sometimes that happens. I've added a couple pieces of 040 styrene strip behind the marker lights on the shell. Next, I'll re-drill the holes through them with a number 76 drill bit. This will give the fiber optics some additional support. Even though a number 76 drill bit is supposed to be 020 in diameter, I had to re-drill the holes with a number 74 bit to get the fiber optics through. This is what I ended up with. The LED blocks are set back a little from the end of the long hood rather than right up against it as I'd originally planned. I routed the wires through the front of the speaker enclosure just like I did with the number board wires. Now's a good time to test the marker lights to make sure they're working right. These look good. The re-engineering was worth it. Now that all the lights are in place, I can seal up the speaker enclosure. I've added some 040 square styrene support rails at a slight angle to bridge the gap between the speaker area and the rear number board light box. This is a piece of 040 styrene sheet that I've cut to fit. I'm using a small round file to make a couple of notches in the back for the marker light wires. I'll glue it in place with some liquid styrene cement. Now it's time to fit the speaker. Since ESU decoders use brown for the speaker wires, I'll use brown for my speaker leads. There's only one speaker in this model, so the polarity doesn't matter. If you use 2 or more speakers, it's important to match the polarity so that they're in phase with each other. The speaker wires are threaded through the last set of holes that I drilled in the front of the speaker enclosure. I'll coat the support rails for the speaker using some RTV silicone, which will act as both an adhesive and a sealant. Now I can add more RTV to seal up the rest of the enclosure. As I mentioned earlier, the RTV makes a good airtight seal, which is important for good sound. Since all of the positive common wires will be tied together, I can bundle and solder all the green wires from the number boards and marker lights. The speaker enclosure is now complete, and that's a good place to leave things for now. Next time I'll wire up the lights on the front of the engine. Coming up with a lighting plan for a model will help to guide the installation process. Be sure to take into account how many lights need to be independently controlled and how many lighting outputs are available on your DCC decoder. I like to test each light as I install it to make sure that it's working as it should. It takes a little more time, but it takes less time than having to rip out a bunch of work and redo it because one of the LEDs is bad. Sometimes you have to find a different way to do something on the fly because the original plan won't work. I had to rethink the design of the rear marker light LEDs to make them work better. That's okay. When doing custom work, things like that come up now and again. I'm pretty happy with the progress that I made with the Conrail engine in this episode. We'll pick it up again next time, and thanks for watching.